Alright guys, welcome to these couple of questions from today. So a bit of a hint about question 1. Okay, you're given the fact that z to the power of 5 is equal to 1. It's got 5 solutions and you're told that alpha is one of those solutions. You're asked to show that the sum of these different powers of alpha is equal to -1. Well, one thing that you can use that would be useful in this here is the fact that if you look at substituting alpha into here and you get the equation alpha to the power of 5 minus 1 is equal to 0. And you know that 1 is a solution to that. So one thing I'd ask you to do is to look at what happens if you were to divide x to the power of 5 minus 1 by x minus 1. Okay, so this would be similar if you had alpha here. So if you did that division, okay, using synthetic division, which will be the quickest, I want you to see what you get if you do this. Okay, we're dividing that by x minus 1. So once you have done that, I'm hoping that when you look at the result, you can see that you might then be able to factorize that this alpha to the power of 5 minus 1, that you can write that in sort of factorized form. Okay, so that's about a bigger clue as I'm going to give for that one. Okay, so pause the video and then try and have a go. Okay, so welcome back. I'm hoping that you've done that division. Okay, and let's see what you get and then how you can use it. So I'm going to use some synthetic division. Okay, we're dividing by x minus 1, so the multiplier will be 1. So what you end up with is this result here. So what that means is that x to the power of 5 minus 1 can be written as x minus 1 times x to the power of 4, 1x to the power of 4, plus 1x cubed, plus 1x squared, plus 1x, plus 1. So if this was alpha instead, we would have alpha minus 1, and then alpha to the power of 4, plus alpha cubed, plus alpha squared, plus alpha plus 1. Now, remember, this is alpha to the power of 5 minus 1 equals 0. So this is simply that alpha to the power of 5 minus 1 written in this form now. So this is equal to 0 here. Now that means that alpha is equal to 1 is a solution, but we're told that alpha is complex, so it means that this here is the part that we want. Therefore, this here is the, not x anymore, this here is, keep doing that, is the part that we want to use. Jeepers. Or in other words, and that's what we're asked to show. Okay, so that's it for that first part. Now, the other part of this question is hence find the equation with real coefficients. Now this here, okay, is just going to once again just give you a bit of a hint here. I want you to have a go. You've got two roots here. Now, what type of equation has two roots? And I also want you to consider that if you add these two roots here, you've got the sum of the two roots, and look at the expression above there, the fact that the sum of the two roots would equal -1. I also want you to consider the product of the two roots. Okay, so that's enough of a hint. So pause the video and have a go. Alright, so for the second question, okay, I want you to remember that if you have a quadratic, that the sum of, and let's say that the roots are, let's say alpha, beta, that the sum of the two roots can be found from the coefficients, that's -b over a, and the product of the two roots is c over a. And also remember this other thing as well, that if alpha and beta are the roots, then x minus alpha times x minus beta, if you expand that out, so x squared minus x alpha minus x beta plus alpha beta is equal to 0. And if we put this in this form here, you can factorize out the negative x, so you get alpha plus beta here, and here you get alpha times beta. In other words, you've got x squared minus the sum of the roots times x plus the product of the roots. So how does that apply here? Well, you're told that alpha plus alpha to the power of 4 and alpha squared plus alpha cubed are the roots. Well, if you look at the sum of the roots, well, that's simply alpha plus alpha squared plus alpha cubed plus alpha to the power of 4, putting the powers in order. And you showed in the first part of this question that that was equal to -1. Now, if you look at the product of the roots, so if you take these two roots that you're given and you multiply them together, okay, that's going to be alpha cubed plus alpha to the power of 4 plus alpha to the power of 6 plus alpha to the power of 7. Now, you may think, well, what are you meant to do with that? Well, the other thing, remember that alpha is a solution to this equation. That means that alpha to the power of 5 is equal to 1. So we can rewrite these powers of alpha to the power of 6 as alpha to the power of 5 times alpha, and alpha to the power of 5 times alpha squared. And remember, alpha to the power of 5 is equal to 1, so this simplifies to alpha cubed plus alpha to the power of 4 plus alpha squared. And once again, you've got that same sum of these powers of alpha, okay, and this is also equal to -1. So then using this idea here, where now we have the product and sum of the roots as simply two values, we can say that our quadratics must be z squared minus the sum of the roots, which is -1 times z, plus the product of the roots, which is -1, equal to 0, so that simply becomes z squared plus z minus 1 equal to 0. And that's the quadratic that you're after. Okay, so we'll catch you in the next part.